every welding environment is different, needs to be evaluated by a qualified industrial hygienist. So that's real important as we go through this and look at as you look at your fume extraction or your exposure limits, just make sure that you do air sampling, because that's very important to do it before and after you use any kind of equipment, including respiratory. So it's really just intended for awareness and educational purposes. And again, this presentation doesn't replace professional consultation. So we're just going to look at process enclosures, local exhaust, some general dilution exhaust, and then personal protection equipment. Capture systems can be a booth, a robotic cell, just a regular canopy hood, fume extractors, using flexible duct, portable ducting, low vac, high efficiency filters. There's electrostatic precipitators, particulate scrubbers, activated carbon filters. These are all elements of your ventilation systems that can be involved. So what welding fumes, different types of arc welding processes, stick, MIG, TIG, plasma, submerged arc, really no fume there, similar to TIG, but cutting tables, carbon arc gouging. As Jeff was saying, carbon arc gouging is probably your highest exposure rate, but plasma cutting can get pretty high as well. So over 500,000 workers in the U.S. are involved in welding-related processes. Exposures is from the mix of fine particulates in the fumes and gases, and just, it's a complex mixture of the metals and metallic oxides. And really, 90% of the fume is respirable because it's less than 1 micron. So that's why all these regulations are there. You breathe it in. That's what can get absorbed into your bloodstream through your lungs. So OSHA personal exposure limits, they've been really enforcing the exposure limits for each individual metal. Somebody asked about Europe or Canada. I believe in Europe, they don't look at each individual metal. They look at the total overall exposure of weld fume. But some of the common metals, zinc, iron, chromium, aluminum, nickel, manganese, which is kind of on the radar for everybody. The American Conference of Governmental Industrial Hygienists, and they kind of they recommend all these limits, which then NIOSH and OSHA review and follow and enforce. So they're always looking at that TLV value on an annual basis. So based on guidance from OSHA, really those samples should be taken inside the helmet. I run into a few places that they put that puck on their lapel or on the jacket, and really it should be done inside the helmets. That's just important to note. So employers must use engineering work practice controls as the primary means to maintain exposures to regulated contaminants. So kind of their hierarchy, so to speak, is first look at your process or your material, and if you can change your process, say stick welding to MIG, you'll greatly reduce that exposure. Even look at the materials themselves, changing materials, lower chromium content materials. Even the coatings on your materials, a lot of times there'll be paint or other coatings on that material. If you can look at that and try to get cleaner material, oils. I've worked with some companies who have changed over from a real dirty material to a cleaner material, and that alone can reduce some of the exposure and just keep the overall environment a lot cleaner. So engineering work practice controls is like a second step, and that would be your isolation or ventilation of the process. Anytime you can enclose that process, reduce it, it creates a barrier between the process and the worker himself. And then you can also ventilate that process when it's enclosed. Good example would be a automation cell that's fully enclosed with a hood on it. So after looking at your process, material changes, your engineering practice, then last step is personal protection. So again, process modification, material change, material substitution, just overall less toxic materials if you can result in overexposure, lower exposures. This is kind of an example. So here's a hood over the top of the robot cell. You enclose that, makes it much easier to capture that fume, and it creates a barrier between the process and the operator. So general ventilation, ambient ventilation, a couple different terms there that people call it. High-powered fans kind of dilutes the air and cleans it throughout the room. You can have systems that do a push-pull, so it may push from one side of the room to the other, or they'll do a racetrack configuration where it's kind of sending the air throughout on a racetrack. That's one way to do it, but you still end up needing respirators or PAPRs, because that doesn't, it works to clean the air in the whole shop, but it doesn't necessarily protect the worker. Local exhaust source capture is probably the best. Again, if you can capture it before it gets into the operator's breathing zone, that is the best way to do it, and that's what OSHA would recommend. Just a couple of the disadvantages of that general ventilation. So again, it can remove the contaminants from the entire facility. Many places have the large overhead cranes, large work pieces. It's just not practical to use local ventilation. So that's where that general ventilation has got the advantage. Local exhaust, several different ways to do that. Canopy hoods, top hoods, slot hoods. That's like a backdraft hood on a workbench where it's pulling away. Got some slots in the back. Fume extraction torches. Not sure if any of you guys have ever tried or looked at those. Certain applications, they work great. That's like the ultimate source extraction. Advantages, captures, again, gets it out of the breathing zone. Disadvantages, just, on the large weldments, overhead cranes, it's really difficult to get the operator to move that hood around every time, so that's the disadvantages of that. And really, can the hood get close enough to the source, unobstructed? Will the guy move it? Again, can you get it close enough to reach that 100 feet per minute? When you get to about 150, over 150, up around 200 feet per minute, that's when it can start pulling away that shielding gas. So it's kind of a fine balance. Maintenance, real critical on local exhaust ventilation systems. If you're not going to maintain it, change the filters, fix any leaks that could be in the system, you've wasted a lot of money. So maintenance is extremely important if you're going to spend the money on this. Just the basic stuff, tell the guys keep their head out of the fume. Keep in mind that the fume has a natural thermal rise. Gentle air movements in the building, opens garage doors, fans, all that can affect how that fume is captured. Just a couple general rules. I always look at it this way. If you have a duct diameter that's coming down to a local exhaust hood, it's about 1.5 duct diameters away as a general rule. Or you look at the diameter of the hood itself, and that's about your distance. It can be a little bit further, but as filters load, the suction gets reduced a little bit. That's about what it is. I'm going to turn it over to Eric, and he's going to talk about respiratory protection.
When it comes to respirators, really that should be the final step. To Jeffrey's point, OSHA would rather not see anybody in respirators, really, because it does put a burden on the welder, depending on what type of respirator they are using. So really, if you can eliminate that fume going to the user to begin with and drop that level down, that's ultimately the goal of a safety manager or industrial hygienist. Really, when it comes to acceptable respirator use, there's really 3 classifications where OSHA would say, yeah, that's appropriate. Really, when the engineering workplace are being used, you want to drop them as low as possible, then supplement with respiratory protection. So if you're not getting those levels down low enough with local exhaust ventilation or process controls, then you can enact respiratory protection. They can be used if the engineering controls, again, have proven to be unfeasible. So if you're doing long stretches of weld, doing large weldments where you really just can't get a fixture there, you're doing one continuous weld where it can't follow along, there is, acceptable use for respirators on that. Also, they should be used while controls are being implemented. So if you have somebody come into your facility, check your air, know that you're above the levels, get the guys in respirators right away until you get the engineering controls in place. When you do enact a respiratory program, anything above a dust mask, so the white dust mask with just the little elastic straps, anything above the use of those, a written respiratory program must be put into place. That program would be, it includes details as, really fume reduction steps up until you've placed the individuals in respirators, why the respirators are being used, who is going to be using them. So which individuals in your facility are going to be using respirators, where they're being used, which cells, areas, fit testing, maintenance, and then also a qualified individual in the company that's going to be in charge of your respiratory program. Really a great resource out there. If you just Google OSHA Small Entity Compliance Guide, it's a great resource. It's about 150 pages. It's a little intimidating at first, but it's a great general guideline. Just follow it through to get your basically written respiratory program in place. It really is well done. When you're choosing the right respirator, there are all different types of respirators out there. So looking at your exposure levels of the actual materials that you're above your limits on, that first you need to do the sampling. Just know exactly what you're dealing with. And then you have to look at the permissible exposure limits of each individual metal. So if you are doing mild steel, so you know what your manganese exposure is, possibly what your hexavalent chromium exposure is. Sometimes metal recycling, you don't always know what's recycled in that batch. There could be fumes coming off of it from other recycled, car bumpers with chromium on them as well. So it's good general practice to know exactly what you're dealing with first. Going back to the one individual's question, if powered air purifying respirators with welding helmet are acceptable. These are all the OSHA classifications of respirators out there. So start off here, the half mask or dust mask that we mentioned. It does have a protection factor of 10. And then OSHA also has a half mask, so more of the elastomeric or like the silicone type face piece. They also classify it as protection factor of 10. Full face piece, and then what we were talking about before is the powered air purifying respirator with the loose fitting head seal. So that is a protection factor of 25. So when we talk about protection factors, that's the amount of, if you look at your permissible exposure limit, that's how many times you can basically, let me jump to I'll kind of explain it. So if you're looking at hexavalent chromium, which is 5 micrograms permissible exposure limit, you could go up to 10 times that exposure limit with a half mask and be adequately protected against hexavalent chromium, or with the PAPR up to 25 times. So really different classifications of respirators have different protection levels that you need to look at while you are choosing your respirator. Really when you're out there in the field, these are really going to be the two most common, the half mask respirator, a lot of elastomeric materials, and then the PAPR. So both suitable options depending on what your exposure limits are. And then also, you won't see these as much, but they definitely are out in the welding environment, is the supplied air, or the full face piece. Those can reach protection factors of 1,000. So if you are in a very hazardous environment, those can definitely be the way to go, depending on what the exposures are. Going back, kind of running through this example again on how to calculate out the proper respiratory selection is finding the permissible exposure limit for the given substance in your facility, then looking at the different respirators, calculating out the maximum use concentration, which is a combination of the permissible exposure limit and the assigned protection factor. So again, for hexavalent chromium, we're looking at 5 micrograms for the PEL, multiplying that by the 25 protection factor of a PAPR with loose fitting head seal. So you can go up to 125 micrograms of exposure. But one kind of caveat to that is that maximum use exposure, according to OSHA, it's the upper limit at which your class respiratory protection is going to be effective. But whenever it approaches that maximum use concentration, you should go to the next level of respiratory protection. Everybody knows your facilities are going to be a little different. You know, when you have 1 dock door open versus 2, stuff like that, there's always going to be some leeway in the exposures to the individual. So that's why they say you want to keep some of that cushion in there so that you make sure that worst case versus best case scenario, the individuals are protected. So if, in this case, if a user was being exposed to 65 micrograms of hexavalent chromium, they would have to jump up to a PAPR. So unfortunately, OSHA does not say within a certain percentage of the maximum use. They say whenever it reaches it. So there's some question there, but really if you're getting close, probably best just jump up to the next level. Really, when it comes to fume management in your facility, it is always an ongoing process. You know, OSHA states that changes that need to be, you know, watched include anything from alterations in production process, different raw materials, different equipment, even different personnel. So if you have one welder on station 2 one day, you have a different welder on that same station the next day. Technically, if it's a regulated substance that you know your limits are close to, that should be tested again. Work practices and control methods, and even different times of the year. You know, a lot of facilities, you know, down south might be having their dock doors open 9-10 months out of the year versus up north where, you know, we have them open 5-6 months out of the year. During the winter, you can have significant changes in exposure limits that OSHA is going to take a look at. You know, they're going to say, well, when was this taken? When was that taken? So, you know, if you are changing your weldments quite a bit, you know, those are all different things that OSHA can look at depending on when your air was tested. So those are all types of things that need to be maintained in a respiratory program and also documented so that everything is covered when or if OSHA comes in and takes a look at the respiratory program. That's it. Just to kind of go back to engineering or work process controls, what Al mentioned, we will have Aaron Bischoff from our Hobart Brothers business unit in this afternoon talk about weld process changes. You know, when we say different materials, but it can also go back to different amperages, different weld settings on your machines to make a more stable arc and produce less fumes. You know, a lot of our field sales district managers go on the field and someone says, man, this machine is spattering, I've got smoke, you know, it's pouring off the weld. They properly adjust the machine to the parameters that should be running for that. You know, this arc becomes much more stable, you get less fume off of it. So those are different things that you can look at as well with your welding engineers. You know, everybody wants to be more productive out there. You know, the supervisor comes over, sets the machine, to walk away. Guys crank it up so then they can get, you know, if they're being paid by piecework, then they can just fly through. So there's a lot of different things. And we'll speak a little bit more to that this afternoon if you're interested.